This is Miss Humbert here. Today we're going to be doing Unit 9, Notes 4. So we're going to be talking about multiplying rational expressions. So yesterday, or on the previous note sheet, you learned how to simplify rational expressions. Now we're going to multiply them. So the first thing you're going to do is multiply the numerators. Remember, when you multiply fractions, you multiply the top and the bottom. So step 2 then is to multiply the denominator, and then you're going to simplify whatever fraction you're remaining. And that's kind of what we did yesterday. So let's take a look at number 1. So for number 1, what we want to do is we want to multiply across the top. So we're going to take 5 times 16, and that's going to give us 80. And then we have a to the first, b cubed, and c cubed that are all going to end up being multiplied together when you multiply across the top. Now we can't add up the exponents of any of those letters because they're the same, or they're not the same letters. Then when we get to the bottom, we're going to take 8 times 15. And when you do 8 times 15, you get 120. And then you get a squared, and then you get b, and then you get c squared. Okay, so then what we want to do is we want to kind of start simplifying this out. So I took a look at 80 and 120, and I want to reduce that fraction. So I looked at what divides 80 and 120, and what I found was 40. So 80 divided by 40 is 2. 120 divided by 40 is 3. So I have the fraction 2/3. Then I'm going to focus on my a's. I have a to the first divided by a squared. So my larger amount of a's is on the bottom, and I'm going to have a to the first, so that a to the first is going to go on the bottom. Then I'm going to take a look at my b's. I have b cubed divided by b to the first. Remember that if there is no exponent, the exponent is 1. So b cubed divided by b to the first, subtract those exponents out and you get b squared. Last but not least, you have c cubed divided by c squared. So when you subtract out those exponents, you get c to the first. So then remember, you don't have to write out the first power. So you have 2b cubed c divided by 3a. So that's your simplified version, but we need to remember to write out any excluded values. So we need to look at the denominator once we multiplied. So we had 120 a squared b c squared for our excluded value. And then what we needed to do is set that so that it does not equal 0. So none of these letters can equal 0, because if they do, then the equation itself would, or the expression itself would equal 0, which we don't want, because then we would have a 0 on the bottom. So those are our excluded values. A cannot be 0, B cannot be 0, and C cannot be 0. Taking a look at number 2, we're going to do 16 times 3. That's going to give us 48. Then when you take g squared times g squared, you're going to add those exponents and get g to the fourth. H cubed times h to the first is h to the fourth when you add those exponents. Then when you're divided, you have 8 times 32. 8 times 32 is 256. So then you're going to have your g. There's nothing to multiply the g by, so that's going to just be g. And then you're going to have h squared times h to the first. Add those exponents and you get h to the third. And then you're just going to have that j squared. So now we want to go about simplifying this. So first thing I'm going to do is reduce the fraction 48 divided by 256. Now both of those numbers are divisible by 16. So I end up getting the fraction 3 over 16. You do have to actually reduce the fraction on the outside. Then we have g to the fourth divided by g to the first. So then when you subtract those exponents, you end up getting g to the third. The large amount of g's is on top, so my answer is going to go on top. And then I have h to the fourth divided by h to the third. Well, that's just going to end up giving me h on top. And there's nothing to simplify that j squared with, so it's just going to stay as j squared on the bottom. So this right here is my simplified rational expression. Now I need to calculate out my excluded values, which comes from here. So we have 256 g h cubed j squared cannot be equal to 0. So that tells us that g cannot be 0, h cannot be 0, and j cannot be 0. So none of those can be 0. All right, so let's go ahead and let's take a look at this next part. So multiplying rational expressions with polynomials. So when you start off with, you want to factor each of them, because that will make simplifying a lot easier. So you're going to factor each polynomial, and then you're going to simplify the fraction. Find the excluded values, and then multiply the remaining values back so we get a polynomial back. So you don't want to leave it in factored form. Okay, so let's go ahead and let's take a look at what that would look like. So for the first one, I don't need to factor anything on the top. I can actually just multiply that out, and I'm going to multiply it as x squared times x minus 5, because that's how we're used to seeing it. We're used to seeing the x kind of on that side. Okay, so then what we want to do next is we want to divide, and we're going to divide by x, but I want to factor this out when I multiply it. So I'm multiplying to a negative 15 and adding to a negative 2. So that's going to be negative 5 and positive 3. And again, the coefficient with my square term is a 1, so I can immediately put this into factored form. Okay, so now I can go ahead and I can cancel some stuff out. Well, this is going to cancel. And then I have to simplify x squared divided by x to the first. Well, that's just going to give me x to the first on top, and then x minus 3 on the bottom. So here is my simplified rational expression. But now I need to find my excluded values. So to find my excluded values, I need to look at my original denominator. So when I look at my original denominator, which is here, I have x times x minus 5 times x plus 3. That cannot be equal to 0. So then x cannot be 0, x minus 5 cannot be 0, and x plus 3 cannot be 0. So when you end up solving all of those values, you get that x cannot be 0, 5, or negative 3. So we need to throw all of those values out because they will make that denominator 0. So let's go ahead and let's take a look at number 4. So we have a 5 that's being multiplied on the outside, and then we have x plus 3. On the bottom, we have x, and then we need to factor that thing right there. So we're multiplying to 12 and adding to 7, which is going to give me 4 and 3. So again, my square term is a 1, so I can do x plus 3 and x plus 4. So then I can go ahead and cross these off. So I have 5 divided by x times x plus 4. Now, before this is completely simplified, I need to multiply that guy in. So then I'm going to have 5 times x, which is x squared, plus 4 times x, which is 4x. So notice once I canceled everything out, I re-simplified that denominator before I could call that my simplified expression. Now, I still have to calculate out my excluded values for that problem. So let's go ahead and let's do that. So for our excluded values, we have x times x plus 3 times x plus 4, and that cannot be 0. So then each of these parts needs to be set so that it's not equal to 0. So then what you end up getting is that x cannot be 0, negative 3, or negative 4 when you solve each of those equations. So those are your excluded values for number 4. All right, let's take a look at number 5. So for number 5, what we want to do is we want to simplify these out. So we need to factor now as much as we can. So what I'm going to do is I'm going to start by factoring out the top. So when I factor out the top, I end up getting negative 4 and negative 3, and then negative 4 and 1. So I have y minus 4 and y plus 1, and then I'm also going to multiply that by the y plus 5 of the other one that's being multiplied in. Then on the bottom, I have y plus 5. Now again, this is one that students kind of forget about. You can take out a greatest common factor on the bottom there. Both of those terms have a y in it. So I can take out a y, and then I'm left with y minus 4. So then I can cross off what's left. So I can cross off this, and I can cross off this and this. And I end up getting y plus 1 divided by y. Now remember, I can't divide those y's out because of the addition there. So that's my final answer for the simplified rational expression. Now I need to go through and calculate out my excluded values. So when I do that, again, I'm taking a look at these right here. So y times x plus 5 times y minus 4 cannot equal 0. So y cannot equal 0, y plus 5 cannot equal 0, and y plus 4 cannot equal 0. Okay, so then you end up getting that y cannot be 0, -5, or -4. All right, so let's take a look at number 6. So for number 6, we have b plus 3 on top. That I can deal with. And then what I want to do is I want to factor out some of these. So for this guy, I'm multiplying to 3 and adding to -4. So I'm going to use -3 and -1. So I have b plus 3 on top times b plus 3 times b minus 1. And that's going to be divided by, now between 4b and -12, I can take out a 4. Remember, GCF does count as factoring. And then I have b minus 3. And then I have, oops, this one should be a b minus 3. Good one, Miss Humbert. And then I need to set up this last x, which is -30 and -7. So to do that, you need -10 and +3. b minus 10, b plus 3. So let's go ahead and let's cancel some stuff out. That cancels. That cancels. So left up top, I have b minus 1 divided by 4 times b minus 10. So to have this fully simplified, I need to distribute that 4 back in. So I get b minus 1 divided by 4b minus 40. So there's your simplified rational expression. Now we need to go through and calculate out our excluded value. So for our excluded value, I'm going to take this entire thing. Well, we know the 4 can't be 0, so I'm just going to neglect the 4 because that's never going to be 0. So I have b minus 3, b minus 10, and b plus 3 that cannot equal 0. So we're going to take and we're going to set each of those factors equal to 0. So then you get that b cannot be 3, 10, or -3 for that one. Now let's take a look at some word problems. So what you're going to learn here is a process called dimensional analysis. So basically it's using rational expressions to change the label to get the answer of what we want. So there are 25 lights around a patio. Each light is 40 watts. So there are 25 lights. Then it says each light is 40 watts. So there is 40 watts for each one bulb. Okay, then we're going to have 1 kilowatt for each 1,000 watts, okay? Because if you look down the road, you want to figure out it's 15 cents per kilowatt. Now, kilowatt means 1,000 watts, okay? Times 15 cents per each kilowatt times 3 hours. Okay, so here's how this works. We have 25 lights times 40 watts per each light bulb. Then there's 1,000 watts in 1 kilowatt. Well, it's going to cost us 15 cents. So if you cross off your labels, this should say this is implying light bulb. So that cancels. That cancels. That cancels. And we end up getting how much it's going to cost us. So when you take and you multiply 25 times 40 divided by 1,000 times 15 cents times 3 hours, you end up getting 45 cents. So that's how much it's going to cost you to operate the bulb for 3 hours. Let's take a look at number 8. So in 2004, the Summer Olympics in Athens, Greece, so we're talking about a 100-meter sprint. So how fast can you do that in a 100-meter sprint in 9.85 seconds? So you can do 100 meters per every 9.85 seconds. It wants us to figure out what his speed was in kilometers per hour. So first I want to take meters and convert it to kilometers. So for every 1 kilometer, there's 1,000 meters. And now I want to take seconds and convert it to hours. So I need to ask myself, how many seconds are in an hour? Well, there's 60 minutes in an hour and 60 seconds in a minute. So 60 times 60 is going to give us 36,000 seconds per each hour. So our seconds cross out and our meters cross out, and we're left with kilometers per hour. So we have 1,000 or 100 divided by 9.85 divided by 1,000 times 3,600. So you end up getting that he was running 36.55 kilometers per hour. Now I know some of these word problems can be tricky, so make sure you ask me for help in class as well. So the velocity of a spacecraft must have in order to escape Earth's gravitational pull is called the escape velocity. The escape velocity for a spacecraft leaving Earth is about 40,320. Whenever you see that per, that typically means you want to set up a fraction. So 40,320 kilometers per hour. We want to set up a fraction. What is that in meters per second? So the first thing I want to do is translate kilometers into meters. So there's 1,000 meters to every 1 kilometer. Notice that I put kilometer on the top and on the bottom so that they would cancel each other out. Then I want to convert hours to seconds. So I want to put 1 hour on top so that my label will cancel. And then I want to put my number of seconds on the bottom, which we decided was 36,000 seconds. So you're going to multiply 40,320 times 1,000, then divide it by 36,000. And then you end up getting 11,200 meters per second is the escape velocity, which is actually pretty cool. So that concludes your note video for today. Go ahead and take your Schoology quiz when you're done. Thanks for listening.